All right, in today's lesson, we're going to be learning more about the angle relationships and finding some missing angle measurements. So adjacent angles, they are side by side and they share a common ray. In this picture, the 45 degree angle and the 15-degree angle are adjacent. Here are some examples of adjacent angles, and you can maybe tell a little bit of difference in the color of the ray, the common ray. They are side by side and share the common ray between them. These are not adjacent. So the top two angles, you have a 100 degree and a 50 degree, but they do not share a ray. The bottom one, you have the 55 degrees and the 45 degrees do not share the ray. And because the one on the right where the lines intersect, they do not share a common ray. Complementary angles have a total of 90 degrees, commonly known as a right angle. Complementary angles add up to 90, so if they are adjacent and complementary, or they could still be complementary, having the same relationship, because that by definition tells you 90 degrees, and not adjacent. Supplementary angles have a total of 180 degrees, so they form a straight line. So again, they could be adjacent and supplementary, or non-adjacent supplementary angles. By definition, it just means two angles that total or sum 180. Vertical angles are opposite of one another. The vertical angles are congruent. So this happens when one line intersects another. So you can see that the two angles opposite the vertice in the middle are each 100 degrees. Likewise, the other two that were not listed must be 80, because there is also a relationship then. If you know one, you can calculate the other missing one using the supplementary rule. So now we're going to do some examples. Find the missing angle. The angles are complementary, so that tells us that they total 90 degrees. So we have an equation that we can write. 36 plus, in this case the question mark, I'm going to replace with an x, will equal 90 degrees. So if I subtract 36 from both sides, I find the missing angle to be 54 degrees. And when I'm finding an angle measurement, make sure that I'm giving the unit label of degrees. In this one, it's implied, it says it's complementary, otherwise sometimes you'll just see the box in the corner to show that it's a right angle. So in this one, I know that I have 3x plus 2x have to equal 90 degrees, combining some like terms to get 5x equals 90 degrees. When I divide both sides by 5, I will find that x in this case is equal to 18. Now this one does not get a degrees because all I have found is the variable part. If I go back and find the actual measures and I take 3 times 18, I will find this is 54 degrees, and 2 times 18 is 36, and from our previous example we know these two to total to 90. Find the missing angle, and the angles are supplementary. Another equation. I'm going to go ahead and use the variable x, so 168 plus x totals 180. Subtracting 168 from both sides, I will find the missing angle as 12 degrees. Because it's the angle measure, it can have the unit degrees. In this case, I want to write another expression and combine some like terms. So I know that 4x plus 5x equals 180, which is 9x equal to 180. Dividing both sides by 9, I will find x is equal to 20. I could plug that back in and get 20 times 4, 480 degrees on this angle, and 5 times 20 for 100 degrees on this angle, knowing that those add up to 180. Okay, find the value of x, then find the unknown angle measure. So some of this work might seem a little bit extra for you to have to do, but I do want you to go ahead and follow the directions and first find x, then find the angle measure. So in the first one, I know that that box indicates that it is a 90-degree angle, even though it does not tell me that it's complementary. I know that a right angle has that notation. So I can write 6x plus the 43.5 will equal 90. Subtract 43.5 from both sides. And I know that 6x must equal 46.5. If I divide both sides by 6, I get that x is equal to 7.75. Then I'm plugging it back in and multiplying it by 6 so that I know that this is 46.5 degrees. For this one, these two must total to 180 because they form a straight line. So I can add some like terms here and get 2x plus 124 equals 180. Subtract 124 from both sides to get 2x is equal to 56. Divide by 2 to get x is equal to 28, and then substitute it back in. 2 times 28 plus 8 will give me 64 degrees. You can check your work by subtracting 116 from 180 to see what this expression needs to be equal to. All right, find the value of x, then find the unknown angle measure. By the fact that they are two lines intersecting, I know that 5x minus 4 must be equal to 58. Definition of a vertical angle. So, if I add 4 to both sides, I get 5x is equal to 62. Divide by 5. Now, I'm not showing all these steps because I'm pretty sure that you guys can do that, so I'm leaving it up to you to show the work that you need to show, that you are dividing both sides by 5 to get x is equal to 12.4. And if I plug that back in and take 5 times 12.4 and then minus 4, it does equal 58 degrees, which I know it should. And also check your work. That's how you're going to know if you're doing it right or wrong. In our final example, in the diagram, we're going to write an expression in terms of x for the indicated angles, and those are all right here. So if I need to know the measure of angle 1, I know that it is supplementary to this angle. So if it is supplementary to 3x, since I don't know what angle 1 is, I can write the math I would have to do to find the measure of angle 1, which would be to subtract from 180 that value of 3x, if only I knew what it were. And I don't have an equation and I'm not solving for x. To write something in terms of x, it's an expression, it will have x in it. So 180 minus 3x would be the degrees for angle 1. For measure of angle 4, it's up here. I know that it is in a supplementary relationship with that variable x. Therefore, I would write 180 minus x would be the measure of angle 4. For the measure of angle 2, I know that the measure of angle 2 is vertical to 3x, which makes them equal. So I would have the measure of angle 2 is equal to 3x. And finally, the measure of angle 9. When I see 9 over here, I see that it is vertical to x. Therefore, it is equal to x, if only I knew what that were. So I've left my expressions all in terms of x to solve. And if you want to, because we are looking for the measures, that would be a way to show the measures. Okay? And if you have any questions today, you can get help while you're working on your homework.